Hey folks, welcome back to your fourth video for your 10.2 lecture series. So in this video, we're going to take a look at a couple more examples on Taylor series and finding the interval of convergence. Okay, so Taylor series at 0 for f of x equals 2 over 1 minus 3x is given by this equation. Okay, now, again, in that last video, I was like, yeah, it's a lot of stuff, but like scan through until you find the coefficients that have the x in it to the n. And here it is, 2 times 3 to the n. Okay. Now, we're not also highlighting the x to the n because we just want to compare the coefficients, like the things in the front. Okay. All right. So first steps first. Let's go ahead and find our a sub n and our a sub n plus 1. Okay, a sub n should be pretty straightforward. We just grab that right from what the equation says, and it is 2 times 3 to the n. All right, now a sub n plus 1, this is where everywhere we see an n, and it's only one place this time, everywhere we see an n, we're going to put n plus 1. So 2 times 3 to the n plus 1. Okay. All right. Step 2, we're going to find our a sub n plus 1 over a sub n. Okay. It's going to look scary in the beginning, but don't forget we can keep, flip, change anytime we have a fraction divided by a fraction. Okay. So 2 to the times 3 to the n plus 1 over 2 times 3 to the n. Okay, well, this time actually there's no fraction inside of a fraction. But do you know what? We could either do it here. This is what I recommended last time. But if you forget, you can simplify that numerator in the second step too. That's okay. All right, what do I mean by simplify? We want to write this as 2 times 3 to the n times 3 to the 1, right? So we're using our exponent rules. 3 to the n plus 1 is 3 to the n times 3 to the 1. And we're going to divide that by 2 times 3 to the n. And this is really nice because look at this. 2 divided by 2 is 1, and 3 to the n divided by 3 to the n is also 1. And so when we divide them, we get a number. Okay, well, let's see what our third step was. Our third step was to find our limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. Okay, so I'm going to find my limit as n approaches infinity of the absolute value of 3. And at first you might be like, oh, this feels so weird. There's not even an n in there. That's okay. Okay. Let's go back for a second, like way back to video 1 stuff. This actually looks kind of similar to example 6 back here. And what I mean by that is when we canceled those out, we just got 7 over 2. And because there was nowhere to plug it in n, it's just 7 over 2. Okay. So even though this is a different equation, we end up with 3. This means my limit as n approaches infinity is just 3. Okay. Well, fine and good that we can do it, but last but maybe the most important step is we have to interpret our results. Okay. So I got a number. I got 3. Let's go back to our chart at the top of the other page. Okay, it's not infinity, so it's not case 3. It's not 0, so it's not case 2. But we got a number. Oh, we got a number, so it means that we're in case 1. And what we need to find is our interval of convergence, like where does this Taylor series converge? We can do that by saying our radius is just 1 over L. Okay. So what this means is that L equals 3 So the radius is 1/3. And we're centered at x minus 0. And I'm going to put that 0 in place because that's going to be helpful for example 3. And I'm sandwiching it between a positive 1/3 and a negative 1/3. Okay, so whatever this radius of convergence is, you take the positive and negative versions. That's your interval of convergence. Okay, now x minus 0 seems silly. I can just write this as x. So really my interval of convergence is just between negative 1/3 and positive 1/3. Okay, so the way we would say this is the Taylor series at 0 for f of x equals 2/1 minus 3x converges when x is between negative 1/3 and 1/3. Okay. So let's get this one all on one page for you so you can see the whole example. And we're going to go ahead and finish this video with example number 3. Okay. All right. We've got a Taylor series at -7. So this one is a little bit different. This is actually one of the questions should be similar in your homework, but I wanted to do one where it wasn't a Taylor series at 0. Okay, so a Taylor series at -7 for this f of x equals 8 natural log of 8 plus x is given by this long thing. Now, using our strategy from before, I'm just going to scan through until I find the coefficient that has the n's. Okay, that's them saying, here's your a sub n. So let's use this to find our a sub n and our a sub n plus 1. All right, our a sub n, according to the formula, is 8 times -1 to the n plus 1 over n. And I'm going to go ahead and split this -1 to the n plus 1 using my exponent properties. So 8 times -1 to the n times -1 to the 1 over n. All right, now find our a sub n plus 1 is 8 times -1. Now, instead of n plus 1, the place where I see the n, like just the n, the green bit, that's where I'm going to put n plus 1. So I'm going to get n plus 1 plus 1 over, instead of n, I have n plus 1. Okay, so really, I did the same thing. Everywhere I see an n, I'm going to put an n plus 1. But we could just call this as n plus 2, right? We don't need to write n plus 1 plus 1. So this gives us 8 times -1 to the n plus 2 over n plus 1. And I'm going to go ahead and use my exponent properties to split the numerator. 8 times -1 to the n times -1 squared over n plus 1. Okay. All right, let's go ahead and find our ratio. So a sub n plus 1 over a sub n. And we're going to divide those. So I've got x, or 8 to the -1 to the n times -1 to the 2 over n plus 1. And I'm going to divide that by my a sub n. So this one we can see starts to look more like the first question where we've got a fraction divided by a fraction. But we know how to handle that. We're going to keep the first fraction, we're going to turn the division into multiplication, and we're going to flip the second fraction. So let's write that. Actually, I'm going to move this whole thing. Let's move this down here. Okay. So this gives us a to the -1 to the n times -1 squared over n plus 1 times, flip the fraction, n over 8, negative 1 to the n, negative 1 to the 1. And I'm going to cancel very carefully here. 8 and 8 go to 1. Negative 1 to the n, negative 1 to the n, go to 1. Nothing else quite cancels except for one copy of this negative 1 cancels with that one. But this n and that n do not cancel because this is an n plus 1, like it's connected to a plus 1, okay? Now, what does that give us? It gives us negative 1 times n over n plus 1. Okay, so our third step, we're going to find our limit as n goes to infinity of the absolute value, that's actually going to be important here, of that ratio. Okay, the limit as n approaches infinity of, what did we get? We got negative 1n over n plus 1. This is where we got to go back to the first video, think about our degrees, okay? And I see that the degree on the bottom is 1, and I see that the degree on the top is also 1. This is where we get to divide our coefficients. So negative 1 divided by 1 is going to give me the limit as n approaches infinity of the absolute value of negative 1. Okay, this negative 1, when I take that absolute value, is going to become a positive 1. Okay, so we've got this positive 1. When we go back to our cases, we didn't get infinity, we didn't get 0, we got a 1. That means my radius of convergence is just 1 divided by 1, or 1. Okay, so let's interpret our results. All right, so our limit is 1, which means our radius of convergence is 1 over L, or just 1. But when we set this up, we're going to have negative 1 and positive 1, but it's not just x going in here. It's actually going to be our x plus 7. Okay, because we're trying to find the Taylor series at negative 7, so x minus negative 7 is plus 7. All right, x plus 7. All right, now this is really two different inequalities. I'm going to subtract 7 from both ends. Negative 1 minus 7 is negative 8, and 1 minus 7 is negative 6. And so what this means is that our Taylor series at negative 7 for this f of x equals 8 natural log of 8 plus x converges when x is between negative 8 and negative 6. And it's going to diverge everywhere else. Okay, so let me get this one all on one screen for you. But I hope these examples were helpful. I tried to pick ones that were really similar to the homework questions, so hopefully you feel a little bit more supported with that. And let me know if you have any questions.